to DR7 LLTng demo. We will be looking at how to use LLTng directly from DevRocket, its features and some of the real-world examples we can detect using LLTng. DevRocket is an Eclipse-based GUI which is used for application and system development. It has ability to communicate with the target, create and manage file system, debugging and system profiling. LLTng is a tracing tool which can analyze Linux kernel, applications and libraries. MontaVista has integrated LLTng into DevRocket environment so we can manage LLTng directly from DevRocket. In real-time systems, priority inversion is a problem which is difficult to analyze. Priority inversion happens when a high priority thread is indirectly preempted by a low priority thread. Low priority thread is keeping the lock, so high priority thread cannot run, and in between mid priority thread preempts the low priority thread, so high priority thread will run at the last and effectively the high priority goes down. Priority inversion caused a major problem on Mars Pathfinder spacecraft. There were 3 threads involved: information task, weather data gathering task, communication task, and they were using a shared resource. Similar kind of situation occurred as I explained before in the priority inversion example. Information task was waiting for weather task to release the mutex. A timer noticed that the information bus was inactive for some time and it caused the system reset. Some other examples we can experience due to priority inversion are dropping frames while playing a video, not responding to user input in a game. The solution to this problem is a shared resource checks if already a low priority thread is acquiring a lock, then high priority gives its priority to low priority thread. This solution is called priority inheritance. Now we will look at how to debug priority inversion from LLTng. I'm launching a CG7 guest using KVM. And I have launched a DevRocket. So we'll go to Open Perspective, Remote System Explorer, and we'll create a new connection to remote system. We'll give the IP address of the guest system. Launch the terminal so we can access our guest from here. Now again go to Open Perspective, LLTng kernel. In the control window, give the connection name. Again the IP address of our CG7 guest. And in the sessions, create session. Enable the events. These are the kernel events we can trace. I will just select only scheduling related events. And interrupt related events. Now just start the LLTng, and in the remote system explorer I'm running a workload which creates 3 threads, and priority inversion problem arises between them. Now I am running a workload which solves the problem of priority inversion using priority inheritance mutex. Stop the trace and import it to our local machine. Now you can say here in the traces, so the traces is our import, and we can filter out our desired workloads from here. I don't want these events. I want priority inversion and priority inheritance workload, and I don't want these events. From this GUI we can easily figure out that high priority thread runs at the last in priority inversion workload, whereas in priority inheritance the low priority thread runs first and releases the resource, and then the high priority thread takes it. We can search for kernel events here. So when we started the priority inversion workload, this kernel event was called. In this way we can analyze the flow of code. So this is the screenshot of what I showed just now. Now we will look at other important features of LLTng, like attaching dynamic probes and context info. We can analyze VM entry, exit, interrupt, CPU, network, etc. from the dynamic probes. We'll create a new session to see how dynamic probes works. So enable event. Now we'll attach dynamic probes. Dynamic probes are we can attach to any kernel function. So this function is called whenever a packet is received. This function is called whenever a packet is transmitted. And this function is called when a socket buffer is freed, and will attach some context information like PID and prop name. These are the information we can attach to the traces. Now start the trace and go to Remote System Explorer. Now I will run the traffic controller command, which simulates packet loss, and these packet loss we will analyze from LLTng. Now we'll just run a ping command. Now I will use a ping command to do packet loss. Now again go to LLTng kernel and stop the tracing. Now import the traces. We can search here for our process name. So you can see the flow of a network packet here. We can see here that a network packet has transmitted, but it is not received and just freed. This packet is transmitted, received, and then freed. This is how we can use LLTng and its features. Thank you.